In the past, we've seen that if we drew a picture of all the solutions to a linear equation in two variables, the picture ended up being a line. So we were talking about equations that look like this. And remember, we called this standard form. This is a linear equation in two variables. And we saw that if we started plotting solutions to this type of equation, the equation we got was a line. So if we're given the equation, a linear equation in two variables, can we actually draw the line? Well, we're actually going to have three different techniques on how to do that. The first one is just what we call plotting points. The second one is still plotting points, but we're going to go after specific points, the x and y intercepts. We'll take a look at that in a second. And our last method, probably our most used method, and it's going to be the last one we learned, is called slope-intercept form. All right, so these are the three methods we're going to take a look at over the next couple of lectures on how to graph lines. So let's get started and take a look at plotting points. All right, the idea for graphing a line by plotting points is if we could find a couple of solutions, let's say two solutions, then that would be enough to know what the line would look like, right? All we'd have to do is connect the dots. Now, generally, all you need is 2 points to draw a line. By definition, that defines a line. However, for us, it's always going to be helpful to put more points on there to make sure that we're doing it correctly. So if you just put 2 points up on the board, there's always a line that goes between them, so you can't tell if you've made a mistake or not. But if you plotted 3 points and it looks something like that, then you know you've made a mistake because there's no way a line can go through that. So generally you almost always want to use at least 3 points to draw a line. Now, to plot points, what we're going to do is make a table of values. Basically, let's start out with a nice easy equation. Let's go 2x plus y is equal to 3. So here's our linear equation in two variables. To make a table of values, generally looks something like this. We have an x column and a y column. We're going to randomly pick values for either x or y, does not matter which one you pick for, plug it in, and then we'll have an equation that only has one letter in it, and we'll be able to solve for that letter. Now, most of the time when we're dealing with equations with two variables in it, most of the time we pick values for x, plug them in, and figure out what y are. So I'm going to pick a couple values for x, and I'm going to keep them small and really close to the origin. So if you want this in your notes, I just picked these, right? These are random numbers I picked. You can use any numbers you want here. By the way, you could have, like I said, you could have picked them for y. Now, for each one of these x values, I'm going to plug it into this equation, then figure out what the y value is. So if I come up here, so for x equals -1, that would be 2 times -1 plus y is equal to 3. Right, all I did is I went into this equation and I replaced all the x's with -1. So it's -2 plus y is 3. Notice we have an equation here with only one letter in it, which means now I should be able to figure out the y value that goes along with that x value. So just solving this linear equation, we get y is equal to 5. So if x is -1, the y value has to be 5. So basically what we've done is we found one point that is on this graph, right? If you plug in -1 and 5, you will get 3. So that point's on that line. So we do this for all the values that we pick. Let's move over here. So for x equals 0, that's 2 times 0 plus y is 3. That one's really easy. That just gives us y is equal to 3. And if you come over and do the last one, okay, 2 times 1 plus y is 3. So 2 plus y is 3. So y is equal to 1. All right, so now we have 3 points on this line, which means we have plenty to draw a picture of. So I'm going to get rid of this kind of our scratch work kind of on the side. So let me go ahead and get this out of the way. Put that one up there in a second. Go ahead and draw ourselves a rectangular coordinate system. And there's our x direction and our y direction. Now all we have to do is plot some points. So we have -1, 5. So it says move -1 in the x direction, 5 in the y direction. So there's our first point. None in the x direction, 3 in the y direction. So don't move left or right at all, but go up 3. 1 in the x direction, 1 in the y direction puts me about right there. All right, so looking at the picture really quick, it does appear that these points are falling along the line. So all you got to do now is connect your dots and you're done. So plotting points, very easy way to graph a line. Ends up being a lot of side work to get it so we can actually plot all the points. So this isn't necessarily our best way for graphing a line, but this is always a way that will work. So if you ever get confused, if you're ever out there, this is for anything, not just lines. Anytime you're out there and you don't know what a graph looks like, you can always just plot a lot of points. So pick a value for one of them, plug it in, and find the other. So that's all plotting points is. A very easy method. The second method we're going to take a look at is, well, technically also plotting points. But we're going to be plotting specific points on our graph. So actually, let me get this out of here and let's talk for a second. X and Y intercepts. Well, we're actually going to be talking about two different points here. Let me do a quick little sketch. Let's say here, X and Y. Let's say we have some line coming through here like this. Now notice I didn't put any marks on our coordinate system here because I really don't care. If I take a look at this point right here, that's the point where the graph intersects the x-axis. This is called the x-intercept. Now notice, anytime that you're on the x-axis, for every single point on the x-axis, the y value is 0. So an x-intercept always has the form something, comma, 0. So we can use that fact to help us find the x-intercept. Now, for the same way, if you take a look at the y-intercept, that's where we cross the y-axis. If you take a look at every point on the y-axis, they all have something in common as well, and they all have the x value equal to 0. All right, so let's take a look at an equation here. Let's start with another one, and we have 2x plus 3y is equal to, I don't know, let's say 12. And the directions for this, let's just say, find the x and y intercepts. Find the x and y intercepts. Well, here's the good news. From now until the end of time, doesn't matter how far you go in math, you're basically going to do this exactly the same way. Well, to find an x-intercept, we know the y value is equal to 0. So we're basically just going to make ourselves a table of values and put 0 in for y. And we know to find the y-intercept, we know the x value is 0. So I'm going to go get this out of here and put us up two very important sentences for x and y intercepts. To find an x-intercept, let y be equal to 0 and solve for x. And the other way around, to find, I guess it's a y-intercept, let x be equal to 0 and solve for y. Again, you really want to memorize these sentences because this is true always. It never ever goes away. So to find an x-intercept, let y be equal to 0, solve for x. To find the y-intercept, let x be equal to 0 and solve for y. So remember, we're looking for two separate points here. So we're going to go after them one at a time. So if we take a look at the x-intercept, we know we're going to let y be equal to 0. So I'm going to take our equation and put 0 in for y. So we get 2x is equal to 12. Nice and easy to solve. We get x is equal to 6. Now remember, we're looking for a point. So our answer is not x equals 6. Our answer is the point 6, 0, right? When y was 0, x was 6. For our y-intercept, basically do the same thing. We're just going to switch it up. We're going to let x be equal to 0. So that's 2 times 0 plus 3y is 12. 3y is 12. Again, very easy to solve. We get y is equal to 4. Remember, y equals 4 is not our answer. We're looking for a point, so this would be the point. X is 0, y is 4. Now, another way to think about this, by the way, that's fine. Another way to think about it is kind of like before when we made our table of values and we picked values for x and y. If we pick the value x is equal to 0 and y is equal to 0, this one here, of course, with our x equal to 0, this gives us our y-intercept. And this one would give us our x-intercept. So we're really just plotting points exactly like we did before, just showing in a slightly different format here. So you could just do the table like this if you wanted to, of course. But you still would have to do this work. All right, so now notice we get 2 points out of this. And technically, we only need 2 points to draw a line. So this is a very quick, easy way to do it because plugging zeros in really simplifies stuff very quick and very easy to do. So you're always going to have to find x and y intercepts no matter how far you go in math. It's one of the major things that we do in courses. So you memorize these sentences and remember to find the x and y intercept. Just plug the other letter in as 0 and solve, and that will give you your x and y intercepts. All right, let's take a look at one more thing here. Let's get this out here. We're going to talk about 2 special lines. Now, what I mean by special here is they're just lines like any other line. But basically, any other line that we're talking about can be written in this form, and this is our standard form. Some number times x, some number times y equals a number. All of them can be written in that form except for 2 of them. And the 2 special lines we're going to talk about are horizontal and vertical lines. So let's take a look at why these 2 may not look like other lines when you write their equation. Again, let's do a quick little sketch. There's x and there's y. Now notice again, I'm not really going to label stuff too much. Let's just say we went up here to a y value 3 and we drew a horizontal line. Act like that's horizontal. Now if I wanted you to find points on this line, all you'd have to do from looking at the picture, let's say we went over to the x value of 2. And I wanted to know what point was on the line at 2. Well, you'd start at 2, you'd go up there and you'd say, okay, that's the point, x is 2, y is 1, 2, 3. So it's up there at 3. So if x is 2, y is 3. What if I came over here to an x value of 10? What would the y value be? Well, that would be also 3. What if I came over here and said negative 500? Well, the y value over here would be 3, right? See, notice it doesn't matter what x value we're at to figure out what the y value is. On this particular line, the y value is always 3. So I don't need to have any x's to tell me what the y value is because y is constant. So since we don't need to know what x value we're at, we don't need x's in our equation. So the best way to describe this line is all the y values are 3. The x can be anything you want, the y is always 3. So for a horizontal line, there are no x's in the equation. So imagine this with no x's in the equation. You could always solve and get y equals a number. So that's the basic equation for a horizontal line. Now if you turn that concept on the side, let's do here. Hopefully that shows up as blue. All right, so on this line, this vertical line here, if you think about it here, for every point on this line, the x value is going to be 2. Doesn't matter what y value it is, the point's always going to be 2 comma something, right? So since it doesn't matter what y value we're at to pick out what x value it is, the equation doesn't need any y's. So the best way to write the equation for a vertical line would be just x equals a number. So here's the clue, here's the hint. If you're given an equation and it doesn't have one of the letters, either it's missing an x or missing a y, that means it's one of these 2 special kind of lines. It's either a horizontal line or a vertical line. And to graph them, it's very easy. To graph, x equals 10. Go over to x equals 10, and since we're missing the y's, we know that it's a vertical line, and draw a vertical line, and you're done. You know, if I say graph y equals negative 3, go down to the y value of -3, draw a horizontal line, and you're done. So they're very easy, quick lines to do. You just have to recognize which one is which. All right, so plotting points is one of the better ways to actually draw a line as far as easiness, but the work ends up being a lot. We're going to see in the future maybe a quicker way to graph lines. But finding X and Y intercepts is a skill that we're going to need in the future. So make sure that you're going through there and practicing those in the homework.